We'll take another circuit diagram. Let's say I have drawn a circuit diagram with a battery in series with an open switch, an ammeter, a bulb, and two resistors in series. Okay, two resistors. All these components, they should be in series. I start with the battery, or simply a line here, it's okay. Or dot, dot, dot. This is the positive, this is the negative terminal. This is the difference between a battery and a cell. You should be very careful. What is the difference between a cell and a battery? A cell, you have only one positive, one negative. Two bars for one positive, one negative. For a battery, you have dot, 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 or simply a straight line here, showing you have several compacted together to form the battery. Then you have an open switch, an ammeter, a bulb, and two resistors, all in series. You can see one resistor here, one resistor here. They are still in series. Okay? All these connected in series. Now, since the switch is open here, no current will flow in the circuit. Now, if no current flow, here the ammeter will give you a zero current. So I will be equal to 0 because the current is 0, the switch is open, current cannot flow. So you don't have to draw directions because here current is not flowing, so you will not have direction of current. So these are all connected in series. If, for example, you are told to draw a voltmeter across the bulb in parallel to the bulb, you just have to add a voltmeter here. So again, all these connected in series, including the ammeter connected in series, but voltmeter in parallel. Now, you may be given a circuit. For example, I have something like this. You have B1, B2, two bulbs. This is a fixed resistor. These are two bulbs. Let's say here I have a switch. This is called S1, S2 here, S3 here. So you have a switch here, another one here, S2 and S3. First of all, the bulbs are connected in parallel. So these two are connected in parallel. Then you have the resistor connected in series in the circuit, including the ammeter. Now, since the switch S1 is closed, current will flow. This is positive, this is negative. The current will flow. Current comes here. Then, this is called a junction. In physics, we call this a junction. So if the current is coming here, some of the current will pass through bulb B1, some of the current will pass through bulb B2. So I have the current coming here from the positive terminal of the battery. When it reaches the junction, some of the current will pass through B1, some of the current will pass through B2. Then the current flows through the two bulbs, they join together to come back to the negative terminal. Let's say if I have a current I here also it will be I, here also I. But here it will not be I. Let's say it is I1, this one is I2. Because at the junction, some current passes through B1, some through B2. But when they join here, it becomes I again. Because I, leaving the positive terminal of the battery, should be returning to the negative terminal. I leaving the battery, I should come back to the negative terminal of the battery. But here, the current will be different because at the junction, the current distributes in the two paths here. Now, what I can say is that I will be equal to I1 plus I2. this I1 and I2, the current flowing through B1 and the current flowing through B2. When I add them together, I should get the current coming to the junction. So if I have I here, some goes up, the remaining goes down. If, for example, here I have 5 ampere, current is measured in ampere, voltage is measured in volt. So if I have 5 ampere here, if 2 ampere flows through V1, so it will be clear that here you will be having 3 ampere because you are having 5 ampere, 2 ampere flowing through B1, the remaining will pass through B2. So you will have 2 ampere here and 3 ampere. And here as well, 2 ampere and 3 ampere. But when they join together here, it becomes 5 ampere. So that's the difference when you have a series circuit and a parallel. In series, current is the same everywhere. For example, here, even here. These are in series. The current is the same at all points in series. But in parallel, the current may not be the same. But the voltage is the same in parallel. So, two things to remember. In series, current is always the same. And in parallel, the voltage, the potential difference is always the same. So, this is one type of circuit that you should know how to solve. I take a simple circuit. Here I have 5 volts. It is the EMF. The battery has an EMF. Here it is the cell. The cell has an EMF of 5 volts. Positive here, negative here, current flows here. Let the current be I. The ammeter will be measuring the current. And here I can place a voltmeter to measure the voltage across the resistor. Now, let's say I place 10 ohm here. So I have a cell with an EMF of 5 volts. I have a resistor of 10 ohm. Now, you should be knowing this equation, V equal to IR. So, V is the voltage, I is the current, or is the resistance. So, you can see here that the voltage is 5 volts, so it is 5 here. The current, I don't know. I have to calculate the current I, or the question can tell you to find the ammeter reading. So, you have I here, and the resistance is 10 ohm. When you calculate now, you will get I equal to 5 over 10 equal to half or 0.5 ampere. 0.5, 0.50 is the same thing. So you get 0.5 ampere. So this is a current. So here you'll be having 0.5 ampere. The ammeter will read 0.5 ampere. Here also 0.5 ampere. Here also 0.5 and returning 0.5 ampere. So it is a series circuit. The current is the same at all points. Now, the voltmeter is placed in parallel to the resistor and it will give me 5 volts. Because I have 5 volts here, the voltmeter will read 5 volts. Now, a bit more difficult question. Again, I'm using 5 volts here. Now I have a resistor and a bulb connected in series. I'm placing an ammeter in series. I'm taking a voltmeter in parallel to the bulb. Now, let's say here I'm placing 10 ohm, here 20 ohm. The bulb here is having a resistance of 20 ohm and the fixed resistor a resistance of 10 ohm. Now, first thing you have to calculate to obtain ammeter reading and voltmeter reading. The question will be telling you to find the ammeter reading, the voltmeter reading, or the current flowing in the circuit. Now, to calculate the current from here, let's say this is I. The current leaving the positive terminal of the battery. Let it be I. To calculate this current, first thing you calculate the total resistance in the circuit. So, the total resistance R equal to R1 plus R2 because I have two resistors, one 10 ohm, one 20 ohm. Even the bulb has a certain resistance, okay? So it is 20 ohm. Here you get 10 plus 20, giving me 30 ohm. So you have in series R equal to R1 plus R2. These two are in series. You get a total of 30 ohm. Now, how to calculate the I, the current? You just have to use V equal to IR. The voltage is 5. The current I don't know. The total resistance in the circuit is 30 ohm. So I don't place the ohm here, just for calculation. So I have the voltage 5, I have the total resistance in the circuit are 30. So I get I equal to 5 over 30. This gives me 1 over 6 ampere. This is the unit of current, which is 1 over 6 ampere. So this is the current that I obtain flowing in the circuit. Now you can calculate this, you can obtain the decimal, it's okay. Now, this is the ammeter reading. This is a current flowing from the battery. And the same current will flow everywhere because it is a series circuit. Current will be same everywhere. Now, after calculating the current, you will be told to calculate the voltmeter reading. Now, you can use V equal to IR. The current is the same at all points, so 1 over 6 is the current. Now, the voltmeter is here. The resistance is only 20 here. So you can see the voltmeter is measuring the voltage, the potential difference across the bulb, and the bulb has a resistance of only 20 ohm. So when I'm calculating the voltmeter reading, I'm using V equal to IR. I is the current flowing in the circuit. The resistance is 20 here. So I multiply by 20. So this gives me 20 over 6. And this gives me 10 over 3. So I can get 3 1/3 volt, 3.33 volt. So you can see here that I have calculated the current first using the total resistance. Then I calculate the voltmeter reading here from V equal to IR again. I get 3.33 volt. Now I got the current, I got the voltmeter reading. Now the total here is 5 volt. Here the voltmeter giving me 3.33 volt. So out of 5 volt that you have from the battery, from the cell, I'm using 3.33 volt across the bulb. So what is the voltage here? What is V here? It's simply 5 minus 3.33. This gives me 1.67 volt. Because the total should give me 5. Because the cell is 5 volt. So if I'm using 3.33 here, the remaining will be here. I take 5, I subtract the voltage here, I get 1.67 volt.